This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on composition of functions. So we're given the function f of x is x squared plus 3x plus 1, and the function g of x is 2x plus 5. We want to link these two functions together. We're going to drop a number in, maybe let's say 7 into g. So we'll get 2 times 7 is 14, plus 5 is 19. We'll take the result of that and drop it into f. 19 squared plus 3 times 19 plus 1. We're daisy chaining the functions, composing them, and trying to see what the resulting function will be. So if we take a look at the following, f circle g of x is f of g of x. So we are dropping the function 2x plus 5 g of x into the function f. How is that going to work? What do we have to examine here? First off, our inside function 2x plus 5 has a domain that includes everything. If g of x is 2x plus 5, the domain of g is all real numbers, and that's important for us to work with, because the domain of g is the maximum possible set we can use for the domain of f circle g. We always have to look at the domain of the inside function before we complete the process. So f circle g of x, f of g of x. What is the outside function? The inside function is 2x plus 5. The outside function is f. What does f do to a number you drop into it? Take that number, square it, plus 3 times the number plus 1. Except we're not going to drop a number into f. We're going to drop the function g of x is 2x plus 5 into f. So it'll be 2x plus 5 dropped here, 2x plus 5 dropped there. So f of g of x, 2x plus 5 squared, plus 3 times 2x plus 5 plus 1. How do we do 2x plus 5 squared? That's 2x plus 5 times 2x plus 5. Make sure you distribute. 2x times 2x is 4x squared, 2x times 5 is 10x, 5 times 2x is 10x, 5 times 5 is 25. So make sure that distribution is done. So 2x plus 5 squared gives us 4x squared plus 10x plus 10x plus 25. Distributing this 3 times 2x is 6x, 3 times 5 is 15 plus 1. Let's get our like terms together here. What is that going to be? 10x plus 10x is 20x, plus 6x gives me 26x. 25 and 15 is 40, plus 1 is 41. So that's f circle g of x. You'll notice that also would be all real numbers. So I'm starting with everything and I'm finishing with everything. So indeed, the domain of f of g of x is all real numbers. Nothing is going to give it a problem. Now I want to reverse the process. Instead of f circle g, let's go to g circle f. So this time we're going to make f the inside function and g the outside function. So we're going to drop this into the function g. We're going to drop x squared plus 3x plus 1 into g, and I have a small typo there that I'll correct. So x squared plus 3x plus 1 is dropped into the function g. What does g do? 2 times the number plus 5. The domain of f is all real numbers. X squared plus 3x plus 1 is a polynomial. Everything is okay there. Again, what does g do? 2 times the original number plus 5, but we're going to drop this function x squared plus 3x plus 1 into g. Dropping x squared plus 3x plus 1 into g will give me 2 times x squared plus 3x plus 1 plus 5. Distributing that, 2x squared plus 6x plus 2. Then we add the 5 on the back end, and then 2 plus 5 is 7, so that we get g of f of x is 2x squared plus 6x plus 7. Notice g of f of x is not the same as f of g of x. Composition of functions is not commutative. Domain issues here. This is also a polynomial, so everything is okay here. Everything was okay on the inside function f here. Everything is okay here on the composition of functions. So indeed, the domain for g of x will be all real numbers. It's not the case with our next example, because what I have here is I have f of x is x squared plus 5, and g of x is the square root of x minus 2. Recall, you can only take square roots of non-negative numbers. So x minus 2 has to be greater than or equal to 0. It is not fair to plug 1 in. It is not fair to plug 0 in. It is not fair to plug in any negative number. So the domain of my inside function g will be values that are greater than or equal to 2. So let's go ahead and look at that. Let's keep that in mind. That's going to be important for us. So f of g of x is f of the square root of x minus 2, but we can never use a number smaller than 2. Our domain for the inside function is x is greater than or equal to 2. Now what? Now we're going to drop this square root of x minus 2 into the function f. What does f do? Squares the original number and adds 5. So the f of the inside function, f of anything, is something squared plus 5. What is the something going to be? Square root of x minus 2. So f of g of x is the square root of x minus 2 squared plus 5, which of course is just x minus 2 plus 5, which reduces to x plus 3, simplifies to x plus 3. Well, looking at this, you'd think the domain is everything, but it's not, because you cannot plug a number into the original function that is smaller than 2. So even though this would be okay for everything, this version x plus 3, the domain of f of g of x must be restricted. It must be restricted to the domain of the inside function. Therefore, the only numbers that are fair to plug into this function are the numbers that are greater than or equal to 2. Our next example is got some interesting algebra and also has something to consider with the domain. So we're going to take a look at what? F circle g of x, f of g of x. Now let's look at the inside function here. Cannot divide by 0. So the domain of the inside function is everything except 6. So we're allowed to plug in anything, any real number other than 6. So we've got to go ahead and keep that in mind. The domain of g of x will be everything but 6. Now we want to do f of g of x. What does f do? 3 over something minus 1. 3 over something minus 1, something being the parentheses. What am I going to drop into the parentheses? The inside function of 4 over x minus 6. So envision this as 3 over that function, 4 over x minus 6 minus 1. That's what we're dealing with for f of g of x, f circle g of x. Now the question is, how do we simplify this? And this gets to be pretty complicated algebra. I need a common denominator in the denominator. So ignoring the top, just looking at 4 over x minus 6 minus 1, we recognize 1 is x minus 6 over x minus 6. That'll be useful. Keeping in mind our domain of g of x, remember we're never going to be allowed to plug 6 in. We're going to rewrite this as 4 over x minus 6 minus x minus 6 over x minus 6. Again, ignoring the top, focusing on the bottom, I have a common denominator of x minus 6. So we've got to take 4 minus this quantity, and that better be in parentheses. So it'll be 4 minus parentheses x minus 6 over the common denominator of x minus 6. That's where our algebra is now. And the next move will be to distribute that negative sign. It'll be minus x minus minus plus 6. So keep that in mind as we continue our analysis. So remember our domain. We're looking at this. How are we going to simplify that? 4 minus x minus minus x becomes plus 6. So 4 minus x plus 6 over x minus 6. 4 plus 6 is 10 minus x over x minus 6. How do we simplify this fraction? Remember, this means division. 3 divided by 10 minus x over x minus 6. 3 over 1 divided by 10 minus x over x minus 6. How do we divide fractions? Multiply by the reciprocal. So times, flipping this, x minus 6 over 10 minus x. 3 times x minus 6 over 10 minus x. Distribute 3x minus 18 over 10 minus x. But looking at that final function, you'll recognize that 10 is not in the domain. Because if 10 were, we would divide the bottom by 0, which is not acceptable. We had to throw out 6 in the domain of g, so we can never use 6. Here we can never use 10. So the domain of f circle g would be everything except 6 and 10. So all real numbers, throwing out 6 and 10. Now, can we reverse this process? Can I give you a composition of functions and you can identify what is the inside function, what is the outside function? So if we're told that f of g of x is the square root of 3x minus 11, what is g? What is f? G is the inside function. G is 3x minus 11. F is the outside function. F would be the square root of x. So looking at this now, inside function, gx minus 11. Outside function, the square root of something. You think about it as the square root of parentheses, but the reality is that the outside function is just the square root of x. Now, can we check that? Let's go ahead and do that. So we want f of g of x, f of 3x minus 11. But what does f do? Takes the square root of something, square root of space. What goes into the space? 3x minus 11. So indeed, f of g of x is the square root of 3x minus 11, and this checks. Let's take a look at one more. So if I've got f circle g of x, f of g of x is 1 over 7x squared plus 5. What makes sense for our inside function? What makes sense for our outside function? I would argue the inside function should probably be 7x squared plus 5, although it could just be 7x squared. A lot of things it could be. But I think the simplest case would be to say that the inside function g of x is 7x squared plus 5. Again, g is the inside function, f is the outside function. I'm going to say the inside function is 7x squared plus 5. Then what do we do with that? We take 1 over that. The outside function is 1 over something. So the outside function is simply 1 over x. Now can we check this? So we'll take a look at f of g of x, which is f of 7x squared plus 5. f is 1 over something. 1 over the something gives us 1 over 7x squared plus 5. And that will conclude this lesson.